Okay, hello YouTube. This is Brad Singh, and today we'll be doing problem from Math Week test 12116. Yeah, that's a middle school test, and we'll be doing team number 9. So in this problem, we have that on an analog clock, basically a clock that has hands, your normal one, not a digital clock, we're gonna go from 12 o'clock to 1 o'clock. And so that's just our hands gonna go that way. And so now we want to figure out what percent of the time is a smaller angle between the hands acute. And so you could do this, right? You could just figure out, okay, when is the angle acute? Because you can probably obviously tell us when to go from being acute to obtuse and then back to acute. And you can figure out exactly what times to do that, but that's kind of difficult. So we're going to approach this in a different way that will be useful for a lot of other clock problems in general. And we're going to figure out basically how fast the clock hands move relative to each other. So we're going to look at a 12-hour period, since after 12 hours, everything resets back to where it was 12 hours ago. So in 12 hours, the hour hand goes one circle, right? Because in 12 hours, this goes in a circle. And the minute hand, well, every hour it goes in a circle. So that's just 12 circles. So if we just take a look at how fast they move relative to each other, well, the minute and the hour hand move in the same direction. So if the minute hand moved 12 times around at the same time the hour hand moved 1 time around, then the minute hand moved 12 minus 1, 11 times more around than the hour hand. So we can say that in a 12-hour period, the minute hand and the hour hand changed by 11 circles. And so we can say this is 11 circles per 12 hours, right? And now what we're going to do is we're going to change this into something that we can kind of have an easier time with. So what we'll first do, right, is we're going to multiply by 360 degrees per circle. And then we're going to multiply by 1 hour per 60 minutes. And so if you do all this, right, you'll get this 11 halves degrees per minute. Okay, cool. This gives us something to work with. So let's consider this, right? That basically means that every minute, the minute hand moves 5.5 degrees more than the hour hand. And so you can see this, right? If we consider in one entire hour, well, what's 60 minutes, which is an hour, times 11 halves, that's 330 degrees, which makes sense because in 1 hour, your minute hand, right, goes all the way around, while your hour hand only goes 30 degrees. And so the angle between them changes by 330 degrees. What's even more useful to know, right, is in these 330 degrees, the angle between the hands changes at this constant rate, right? So what do we have? Then we have that basically, you can think of it as, let's just draw another circle. This represents the angle between the two hands, and it steadily increases from 0 degrees up to 330 degrees. And so now again, we ask the question, what portion of the time is a smaller angle between the hands acute? Well, the smaller angle between the hands, right? If it's going to be acute, it has to be either less than 90 or greater than 270, because if it's greater than 270, then like the smaller angle is 360 minus that. So what we're actually looking for, right, is in this big area, what portion of the circle is acute, which is in this area. And now this becomes rather easy to see, right? This is just like 12 slices of a pie. What you have is you have 3 slices of a pie here and then 2 slices of a pie here out of 11, because we're not counting this, right? We're not counting this. So that's 2 plus 3 over 11, which is 5 11ths. And there we have it. And so basically, notice that like instead of like figuring out what time it was, we'll probably change it around like 1:16 and like 2 11ths or something. But like that's really hard to calculate. Instead, what we did is we just calculated how much the angle between them changes, and that's going to be really useful. Instead of actually looking for the exact answer we need, we can we can get our answer by inferring it from another method.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.